Today we will talk about momentum. So momentum is a very important concept on physics. The letter that we use for momentum is letter P, and it is a vector quantity, and it is said that if the object has a mass and it is moving, then it possesses momentum. And momentum is the product of mass and the velocity. Let's recall here that the velocity is a vector quantity, which means that we will have magnitude and a direction for the velocity. And then we notice here that since mass is a scalar quantity, and it is always positive, we can say that momentum and the velocity have the same direction. So when you know the direction of the velocity, then you know the direction of momentum. When you know the direction of momentum, then you know the direction of the velocity. Let's see some examples now in which we are calculating momentum. And in different situations when the velocity and mass are given at the proper units and so on. So let's suppose that we have a question as what is momentum of a car with mass 1.32 times 10 to the power of 3 kilograms, and it is traveling with a velocity as 3.20 times, no, not times, 3.20 meters per second going west. So in this case, what we are looking for is momentum, and what is given is mass of the car as 1.32 times 10 to the power of 3 kilograms, and the velocity is 3.2 times 10 meters per second going west. So now if you re-emphasize what we said, and if I ask you what is the direction of momentum, you will say it is going west. Definitely is going west because the mass or the velocity and momentum have the same direction. And in this case, the direction of the velocity is known as west. Therefore, the direction of momentum will be the same. But in terms of the magnitude, or the formula that we will use, will be mass times velocity, which is 1.32 times 10 to the power of 3, and it is in kilograms, times 3.20 meters per second going west. So if you use your calculator, you will figure out that momentum is, what the calculator gives you is 4224, and the units are kilograms meters per second, and the direction is the same as the direction of the velocity going west. Now, when we see this, this has 4 significant digits. When we see this number that the calculator gives us has 4 significant digits. However, in our question, everything was on 3 significant digits, so the lowest. Therefore, the answer will be expressed in 3 significant digits. So what do we do in this case? We move the decimal point, and then we will have 4.22, and we don't round up since 4 is less than 5, times 10 to the power of 3 kilograms times meters per second going in the west direction. And this will be your answer for the question. Now, if the velocity is, let's suppose, north of east, south of west, an angle or whatever, then will be the same logic. So you don't have to find out the direction of the momentum when you do know the direction of the velocity. So let's see another example here where we are talking. So example 2. Let's stick with the car. Again, we have a car that has a mass of 1.50 times 10 to the power of 3 kilograms, and the object is moving with a velocity of 2.80 times, not times, meters per second squared, meters per second at 25 degrees south of east. And we are looking for momentum of this car. Now, if they are asking for the direction, then the direction will be the same as the direction of the velocity, will be 25.0 degrees south of east, because the momentum and the velocity have the same direction. Now, what we will do here, in top of finding the momentum of this car, we will find even the horizontal component and the vertical component of momentum for this car. So let's start with the momentum. So we'll have momentum is mass times velocity, which means that will be 1.50 times 10 to the power of 3. And I'm just omitting the units now, since they are the same, or the units that the momentum is accepted, times 2.80, and momentum, this is at the direction of 25 degrees south of east. So in your calculator, 1.50 times 10 to the power of 3 times 2.80 will be, what the calculator gives you as 4200 kilograms times meters per second at 25 degrees south of east. And to express this at the proper significant digits, we will have 4.20 times 10 to the power of 123 kilograms meters per second at 25 degrees south of east. And this will be the answer to the first part of the question. So this is this one here. And now when we are finding the horizontal and the vertical component of this, what we will do, same as in every single vector that we have worked with, this is a vector that is between south and east, so south and east, and that the angle with east is 25 degrees. So this is the vector P with a magnitude of 4.20 times 10 to the power of 3. And the angle here is 25 degrees. So then when we are finding the horizontal component, what we are doing from the tip of the vector, we are creating a 90-degree angle that includes, or the right angle triangle that includes the given angle. And then this is forming two components. So the horizontal component is whatever is along the horizontal. So this will be the horizontal component, and the vertical component will be whatever is along the vertical component. Now, using sine and cosine ratio, we will find the horizontal component as positive because it is going in the east direction, and will be 4.20 times 10 to the power of 3 times cosine 25 degrees. Make sure that the mode of your calculator is in degrees, because this is a common mistake that is happening, especially to students that are taking math at the same time as they are taking physics. So this will be 3.80 times 10 to the power of 3 kilograms times meters per second. And this will be the horizontal component of the momentum. And now the vertical component of momentum of the car will be negative because it is going in the south direction, and it is 4.20 times 10 to the power of 3 times sine 25 degrees. And again, please, 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 it's a very common mistake. Make sure that you are the mode of your calculator is on degrees. So this will be 1.77 times 10 to the power of 3 kilograms, and it is negative times meters per second. The next example will be where we convert the kilometers per hour into meters per second. Again, let's suppose that we have a car. The mass of the car is 1.47 times 10 to the power of 3 kilograms. And then you have the velocity of it moving with 62.0 kilometers per hour at 40 degrees north of west. And again, what we will do is we will find the momentum of the car in kilograms meters per second, and then we will find the horizontal component and the vertical component of this moment. So momentum is again mass times the velocity, which means that will, in our case, will be 1.47 times 10 to the power of 3. It's kilograms times the units for the velocity are kilometers per hour. So since the units that the momentum is required for us to be is in kilometers per hour, the very first thing that we have to do is we have to convert the 62 kilometers per hour into meters per second. And how do we do this? So we start with using the factor label method. So it is our unit analysis. Then we start with multiplying it with the ratio of 1. So 1 kilometer is 1,000 meters. So kilometers and kilometers is cancelled out. And then in 1 hour, we have 3600 seconds. You can go minutes and then seconds, but now we have done so many of them, so it doesn't really matter. And when you enter it into your calculator, will be 62 times 1,000 over 3600, and the units are meters per second, because what is left here is just meters per second. And when you enter it in your calculator, you will have the velocity as 17.2 repeating meters per second at 40 degrees north of west. So then we will enter this value into our formula for the velocity. So for the momentum, and it will be 17.2 meters per second at 40 degrees north of west. Because momentum and the velocity have the same, keep that in mind every time that even they are asking you what is the momentum, then what is the direction of momentum, then if you know the direction of the velocity, you don't have to do any calculations for that. So when you enter it into your calculator, 17.2 will be 2.53 times 10 to the power of 4 kilograms meters per second at 40 degrees north of west. And now on your own, you stop the video here and on your own find out what is the horizontal component and vertical component, and I will give you the answers so that you can check. So stop the video now and then you will see the work and the answers of horizontal component and vertical component of momentum. So this is the work and the answers for horizontal and vertical component. Do not forget to state the sign, especially when you are working, like you are handing in work or you are answering the question to the quiz or test or whatever assignments, whatever we are doing here on physics. Your work should match this one here. And if you don't, then you should refer to finding the horizontal component and the vertical component video of any vector that is posted on Google Classroom. Okay, so one more thing for this short video that we are doing today is that we will talk about systems. So in physics and in science in general, what we talk about, there are 3 types of systems. And when we are saying systems, means that we are talking about the what is happening in what is happening with all the objects that we are taking into the considerations. So systems are 3 types. So the first one is closed system. So in a closed system, what is happening is the mass and it doesn't change. So no mass leaves or enter into the system. Then next type of system that we talk about is that is known as the isolated system, where no external forces, act on the system and no energy leaves the system. So no external forces and no energy change. So when we are saying no external forces, so no other forces beside the forces that we are taking into the consideration. The third type of system that we talk about is that is known as the open system. We will talk more about this when we see the conservation of momentum, but just as you know, mass may enter or leave the system and internal forces can influence the system. So mass enters or leaves. And external forces, I will say, are present. Are present on the system, and then that means that they may influence the way that the system acts or deals with. So motion of the system or anything that is the system. The system is happening. And then again, when we talk about system here, what we are keeping in mind is that the objects that we are taking into the consideration and environment that the object is on. This is the system. Okay, so this will conclude the first short video of the first of the momentum, and we will talk more about the system and other stuff in momentum. So this is the first part of the video.